Wärtsilä's video series on fire safety. I am Darryl Furlong, Director of Product Management and Power Engineering for the Energy Storage and Optimization team. As the world's third largest integrator of energy storage projects, we have over 7.5 gigawatt hours of grid-solved quantum product deployed across 6 continents. We have a fundamental commitment to safety. We are very proud of our 100% track record with grid-solved quantum product. In our discussion between our safety engineers and outside industry experts, we will be covering topics related to product design, product deployment, stakeholder training, and site testing. Now, over to our fire safety engineering team. Thank you.
Hello and welcome. My name is Mishaal, SyedNaveed, and today we'll be discussing about fire safety and fire protection in this video series. And I'm joined today with Dr. Noah Ryder from Fire and Risk Alliance. And we'll be discussing some interesting things regarding permitting and permitting packages. Noah, how are you?
Good. Thanks for having me on. And it's amusing you use the word interesting and permitting in the same sentence there, but we'll see what we can do to keep folks engaged throughout. So appreciate helping out here.
Absolutely. Wärtsilä is proud to hold a 100% safety record for our grid-solved quantum energy storage system. We're here with Noah from Fire and Risk Alliance over a great partnership that we've built. And today we'll be discussing more in detail about all the great permitting packages that we've worked alongside of each other with.
Yeah, thanks. And just as a quick, intro to us, for anybody who's not aware, we're basically a fire and life safety engineering specialty firm. And we're small by most company standards, but big by fire protection engineering standards. We've got just over 50 people kind of scattered across the U.S. And in North America, but have done work pretty much all over the world, and always enjoy getting involved in challenging problems. And that's kind of what we've been doing since our founding. So happy to do this on the ESS side of things and working with you all.
Great to have you. So let's get started. In a complex and rigorous planning stage for energy storage projects, what are some key analyses for developers and end users to utilize and essentially focus on their projects to be as safe as possible?
Yeah, so obviously every project is a little bit different, but there are a few kind of key documents that are pretty much uniform, and we tend to see kind of not just within the US, but internationally and anywhere that ESS is being deployed. And so the big one that is pretty much universal is the hazard mitigation analysis. Most people refer to it as an HMA. And you'll hear us say that, consistently throughout. But that is really kind of the key document that looks at how these systems operate, how they might fail, and evaluating the safety and mitigation features that might be there. And so that's kind of the big overarching document. The next one that I'd say comes up, pretty regularly as well is whereas the HMA is focused kind of within the site limits, is a community risk assessment. And you may hear different terms for that, like a fire risk assessment or fire risk analyses or what have you. But in essence, that document, that approach is really looking at trying to see what happens, from an exposure standpoint, not just within the property boundaries for the fire service and first responders, but also what's happening or may happen outside of it. We know that these are pretty rare events, but we want to be able to have the pieces in place to educate people about what to expect, whether that's the public or the fire service or whomever. And then kind of to your question, the last one that I'd say is pretty common that you might come across is a site design guide. And so why I say it's common, it can be it's relatively unique coming from an OEM or a manufacturer. I know you all do it. Maybe there's one or two others that do, but typically at some stage in the project, there's going to need to be a basis of design that kind of drives everything. And so the site design guide, if it's available at the beginning, kind of ensures that all the best practices as it relates to fire protection and life safety and so forth are there. It's put kind of in black and white on paper, and you can kind of run with it. So those are kind of the three big ones that are really focused on the site itself. And then the last one is related to the first responders themselves, and that's the emergency response plan or the emergency response guide. And that really just focuses on the hazards that might be there, is established to try and make sure that the fire service knows what they're dealing with, what they might come across, gives them some tactics about how to address it, but also just, kind of boilerplate or, basic information about who to contact and information and that kind of thing. So those are kind of the things that you might see pretty routinely with these types of sites.
Yeah, exactly. So we're seeing, I know personally we've received inquiries about HMA, the hazard mitigation analyses, the CRA, community risk analyses, site design guide, excuse me, and then lastly, the emergency response plan. Definitely important packages to deliver for AHJs and customers. Why are these analyses important? Who is actually reading these, and what challenges are they solving?
So who's reading them? Who's taking a look at it? It depends, right? They're winding up on a lot of different people's desks, and hopefully most are actually reading them. But they can be pretty dense at times, so maybe a skimming at minimum. But they're all kidding aside, they're important because really there needs to be a focus on safety. And that tends to be everybody's kind of top priority, but sometimes can be pushed a little to the wayside or not well understood, especially in evolving markets and new technologies and things like that. So making sure that these are developed and done well, that they're distributed so that the authority having jurisdiction or the AHJ or the fire service or the community kind of understands what's there, and can absorb that information, is really the key to it. So if they're not present, then there's just a vacuum of information, and whether it's talking about energy storage systems or anything, kind of in a vacuum, they're going to just fill it with stuff, and usually most of it's wrong. So it's important to get this out there, and into the hands in particular of the AHJ themselves, the fire service, or the community, and in some cases all three, depending on what the document is, because those are really kind of the stakeholders of the project outside of the OEMs and the site developers themselves.
Yeah, exactly. Well said. Now let's go deeper into the hazard mitigation analysis, the HMA, like we colloquially call it. Let's dive deeper. So for an HMA, what stage of the project should teams begin putting together this document, and what does it really entail?
Yeah, so kind of as I alluded to earlier, we have a phrase that we say frequently. It's as early as possible and early and often, and that holds true for the HMA development. The final product that is delivered, obviously relies on a lot of information in terms of the specifics of the site, and so you may have to have draft HMAs and so forth in the interim. But ideally, that process should start early. Best case scenario, you're working with a technology that's known. Like for you guys, I know you have a baseline HMA that can be distributed. So a lot of the upfront information about the product itself and the basic design features and so forth are already there. They're already encapsulated in the document, and so that really can give either the fire service or the AHJ or whomever is looking at it a good head start. In terms of what they're looking at, and even if the specific details in terms of megawatt hours and the specific of the site layout and so forth aren't known, a number of the details are already available. So that can really help to answer a lot of questions and so forth that may come up. So that's kind of our take on it, and our preference is to get that at least in some form done as early as possible.
Yeah, absolutely. And I know when we have meetings with prospective customers, this is coming again and again. Do we have an HMA? Do we have these permitting packages? And I'm honestly glad we have a generic one that we can share with customers, which eventually can be made site specific with your help and your team and efforts as well. So talking about elements of an HMA, what's really in it?
Yeah, so the HMA is a code-driven document, or it's required by code. So NFPA 855 addresses it, and the International Fire Code addresses it, and then any of the states that have adopted the IFC and you modified them, added their own amendments and so forth. There's some reference and folding in of the HMA. That being said, it is actually pretty limited in terms of its description within the code. So there's really 6 or 7 basic questions that need to be answered in the HMA, but a lot of those are actually tailored at facilities or operations where the batteries might be put indoors, and obviously that is occurring somewhat more frequently, but most of the installations, in particular at grid scale, are happening outside. And so they're, put the battery enclosure outside in a field somewhere or in a cleared area, and there's no structure around it. So some of the things that the code actually calls out aren't necessarily even pertinent. So what we see happening and what we kind of look at is really addressing the key safety concerns overall. And that is what's happening from a fire exposure standpoint. Do we have to worry about spread from one enclosure to the next? Is there a deflagration hazard within the enclosure itself, and what might that do if there's people around? And what also has happened at the testing level. So all of these systems are required to go through pretty extensive underwriters laboratories or UL testing. The test standard in particular is the 9540A standard. So you'll hear that bandied about. But that tested at the cell, the module, and the unit level. So and those are kind of the building blocks of the battery pack. So once those are done, then the HMA also kind of summarizes those and incorporates that. And so that's kind of the key things that are there that characterize both the mitigation systems as well as the battery performance, and then any approaches that might be taken at the site level in terms of prevention, mitigation, fire department access, and so forth. That's, in an ideal world, kind of all rolled up into the HMA.
Yeah, exactly. And obviously not every project will be the same. Different sites require different versions of the HMA, and those can be made site specific. But could you tell us about one of the more unusual or distinct hazards that a project has had to plan around?
Yes, so good question. I'd say there's probably kind of 2 different things that come to mind. I'll touch on, and one is very dense kind of urban areas where oftentimes large sites are placed with areas or sites that have a lot of acreage, and there's a lot of free area around it. There may not be a whole lot of exposures. But if you take that same thing and you put it in a street corner, kind of in downtown Chicago or downtown New York, all of a sudden, it changes it significantly. You might have smaller systems, right? Overall, you might not have as many containers, but the exposures can be different. So we've had situations where, quite literally, we've had an energy storage system that was across from a church that was down the street from a daycare, and had a convenience store across from it. And again, this wasn't, a massive system, but, still fairly large and in close proximity. And so, when you're looking at that, then you're addressing a different set of kind of risk criteria and things that you just need to account for. And so in that case, your HMA is probably going to look different than if you're doing something where, there's really nothing around you for quite some distance. And, events, even if they were to occur, are, barely would go noticed. The other one that's a little more challenging, that's unique, is anytime you put something indoors. And so obviously if it's indoors, then you're typically going to be dealing with more people. You're going to be dealing with the building structure itself and so forth. So then it kind of takes on another level of analysis that gets folded in. Those are kind of the two big ones that just kind of immediately jump to mind.
Yeah. Like the name says, hazard mitigation analyses, different hazards, different mitigation strategies. Let's shift gears more towards the next topic, which is the community risk analyses. Are local people generally engaged in the projects that are being built in the communities? What have you seen from your experience? Are they more interested now that they see lithium-ion in the news, whether good or bad?
Yeah. So, there's no universal answer to that. I think a lot of it depends on where these systems are going in and the scale of them and what's around them. And for instance, talked about the one in the urban area that was close to a lot of things. So there was a lot of community engagement there. There was also a lot of outreach from the developer to make sure that the community was engaged. They didn't want to catch them by surprise with anything and so forth. We've also had large projects that, basically, the community was equally as engaged, for better and for worse. There's a lot of issues surrounding energy storage, and so sometimes, lack of understanding or just, preservation of the way things are, whatever it happens to be, can create some pushback, and we can see that at the community level. What we try and focus on really is kind of staying largely away from that and focusing on the safety aspects of it, and how they can be operated safely, showing that through the community risk analysis, sometimes comparing them to other risks that may be in their purview or daily activities, just to kind of give some frame of reference. But in general, what I'd say is that we are seeing more engagement. Certainly, anybody that has a TV or a smartphone has seen the news, and the news is all about getting clicks and eyes on it. So any little thing that happens in the ESS, in the energy storage world, makes the news, and so that's getting the communities kind of more engaged in the process. And then the last thing I'll say kind of there is that a lot of folks hear about it from like micromobility devices, and they'll say, oh, it's a battery fire, it's a lithium ion battery fire, these are bad, and so forth. And so one of the things we try and emphasize and explain is that, hey, they both are lithium ion batteries, yes, but they're very different in terms of the testing and everything else that goes into them, and the level of rigor that is involved in the design and in the costs and so forth. And so it's kind of like an apples and oranges comparison, and we try and just bring it back to really the battery storage systems themselves.
Yep, exactly. We're not dealing with something totally different. It's just a different animal that we've dealt with before in different forms. So yep. Now, in terms of the actual community risk analysis, CRA, what are the main components of that analysis? What risks do we have to account for in that?
So when we do a risk analysis of most any kind, we can pretty much break it down into three main areas that we're concerned with. So the first is basically a fire or thermal exposure, right? So are there people or equipment or other things that could be impacted by that? The second one is an overpressure, or you'll sometimes hear people use the word explosion or deflagration, but basically it's some event where there's some overpressure associated with it. And obviously examining whether that has the ability to occur, number one, and then two, what the impacts might be, again, to people and equipment and so forth. The last one is related to toxicity. So if we look at those three different kind of hazards, that's pretty much what constitutes the bulk of the analysis. And there's a lot of pretty complicated calculations and other things that can go into it, but we're really just looking at those three things. And what the exposure may be to folks within the site that may be responding, to an event, and then folks outside of it that may be, waiting for information in terms of, how they should respond and what they may need to do, and if it's, safe and those kind of things. So that's really what we kind of try and tie into the community risk analysis, or the CRA itself.
And are the results of these analyses presented back to the community?
Again, it's one of those where it's really dependent on the project, but our objective when we write them is to present it back to the community in some form. Oftentimes, our reports might be, 50 or 60 pages that are heavy technical. So we might not plop that right in front of them, although we usually make it available, or the client will make it available. But at a minimum, what we try and do is summarize that information in a more readily digestible fashion. Kind of highlights what the results are, shows what the extent is, discusses what the impacts, if any, may be, then kind of work from there. But yeah, this is, as the name implies, it's community in twofold. One is it's evaluating it, and two, it really is intended for the public to look at, because our impression and our perspectives, we don't want to hide anything. We'd rather, for better or for worse, if there are questions, if there are concerns, that we can address them, and so yeah, we tend to push for that personally in terms of availability.
Yeah, just to echo that, Wärtsilä is very transparent with our customers as well. We provide all these analyses, we give it to the customers, and it is available to the public in some form. Yeah. So now shifting over to the site design guide. I know we talked about a community, we talked about hazard mitigation analyses. Overall, how does a site design guide mitigate safety risks?
So the hazard mitigation analysis in the CRA are kind of focused on the after effects. It kind of assumes that something is going to go wrong, and this is a little bit of a slight tangent, but from a fire safety standpoint, that's kind of the point of fire safety, right? So most of us have been in buildings before, and if you look up, you've seen sprinklers. A very, very small percentage of those buildings are ever going to have a fire, and those sprinklers may never activate. So the building may go its entire life and the fire protection system isn't used, but we still put it there because we know there's a chance that it could, and we want to mitigate the risk. So the HMA and the CRA kind of go with the assumption that something could occur, even if that probability is very, very low. And you referenced your safety record earlier. By and large, these incidents do happen pretty infrequently. So the difference with those and the site design guide is the site design guide is kind of the upfront work to say, well, what can we do and what can we put in place to try and make sure that these events don't happen to start with, and then how can we what systems are going to be there that will help us mitigate it if it does. And so that is a combination of code requirements that might be there from the NFPA 855 or the International Fire Code, or fire department standards that exist for NFPA and other things in terms of fire hydrants and so forth. All those kind of get wrapped up into the site design guide that is really intended for both the developer, the owner operator, and even to some degree with the first responders about what the site is going to have, what's going to be required, and so forth, as it relates to fire detection systems, fire suppression systems, the monitoring of those, and all of that kind of gets captured at the fire alarm control panel, and what that's going to look like, for somebody that shows up and is trying to get information about it. So that's kind of what the site design guide does, as opposed to, say, like the HMA or the CRA.
Exactly, and I just want to reiterate that statement of the site design guide tells you or provides the knowledge of what not to do in an abnormal scenario. That is key. So what information does the site design guide provide to first responders? I know we've been talking about from a customer perspective. Now let's shift gears onto the first responders.
Yeah, so the site design guide itself, what I will say is, one is the first responders may not actually look at it that frequently, but the site design guide, if it's coming from an OEM or somebody else that is providing it, the information that the first responders might need in particular are things related to, fire department access. Where do they get in? What's going to be provided in terms of the fire alarm control panel or the first responder station, which is kind of, the central hub for them to look at things. You also hear fire command center. All those terms are kind of, generally the same, but it's the location that the fire service and first responders can go to pull information about what's happening at the site and so forth. It also can lay out where fire hydrants are, if there's fire department connections or details on the water supply and so forth. And so all of that is generally going to be wrapped up in the site design guide. The fire department may actually see a lot of that when it's rolled into the emergency response plan and the emergency response guide. So some information you'll see in some of these reports is, may be duplicated because the reports are kind of tailored for each of the stakeholders. So you'll see some carryover there, but that's the kind of the bulk of the information that the first response folks might get out of it.
Yeah, absolutely. And that first responder station is key that Wärtsilä does provide for sites and customers to utilize. Now to wrap things up, I know we're running short on time, but are all three of these analyses really required? How do they integrate within each other?
So that's a good one. The state of our code adoption in the U.S. is pretty fragmented. So the short answer is no, they're not all required everywhere, and in some cases, none of them are. And that's largely because every state adopts its own standard at different times, and so some may be operating off of NFPA 855, some may be operating off the International Fire Code. But some may be operating off a code that's 10 years old and they don't even reference energy storage systems. So What I'd say is that they're not required, but as a best practice, they would be provided. The HMA itself is probably the one that is the most typically required, because the more recent editions of the International Fire Code and NFPA 855 both specifically require one. So I don't know what the exact count is from a state's perspective, but it's probably 2/3 of the states or somewhere in that vicinity have a specific requirement for that. And then individual AHJs and such may require things above and beyond as well. So even in certain states that haven't adopted it formally or made it mandatory, localities might. But I'd say that the other two documents in particular, the site design guide and the community risk analysis, are really kind of just best in class, I'd say. That ideally they would be provided for pretty much every project, because the information that's contained there is really important to creating a holistic approach and picture of what's going on and what needs to be done. And sometimes if you're missing one or more of those components in those documents, then you may be missing pieces of the puzzle. So that's kind of a long way of saying that no, they're not all required, but that's typically what we would push for. I know we've obviously supported you all in doing that, and that's kind of status quo for you all as well. But yeah, that's kind of where it sits today.
Yep, and whether they're required by code or not, AHJs definitely want to see this information. They want to get a hold of this. They want to be able to provide it to their folks, and education is key in this instance. And it's and honestly industry best practice to have these prepared. I know Wärtsilä has all these permitting packages ready and available with their team's help and efforts, and we're really progressing and keeping that 100% safety record to date.
Yeah, I would just echo that yeah, for sure, it is something that more and more is being requested, just to satisfy questions, and also just from an educational standpoint. There's a lot of really good information in them, and it can really help both developers and others to kind of de-risk a project, in terms of making it commercially viable, but also in terms of the AHJ and in the community, and understanding what the systems actually are. Once they understand what they really are, then we tend to see much less concern as it relates to them. So it's a good thing all around, in addition to just being good sound engineering and safety.
Awesome. Well, Noah, it's been a pleasure. Thank you so much for your time and on this episode of our video series, and a special thanks for all the viewers tuning into this series and learning how Wärtsilä is advancing our robust approach to safety. Appreciate it. Thank you so much, and have a wonderful day.
Thank you for joining us and our guests on this series on fire safety for the energy storage industry. As you've learned, fire safety is a critical subject for the advancement of our industry. Safety is at the foundation of everything we do here at Wärtsilä. Our design approach to safety is comprehensive and is aimed at de-risking the total cost of ownership throughout the project lifecycle. To learn more, please visit us at storage.wärtsilä.com.